Welcome to Spring LIB.
All right, so we've got T-butyl iodide reacting with sodium methoxide, which would be like sodium plus with oxygen and a methyl group, right? And does this go is the question. Does this reaction work? Versus we have methyl iodide, meaning instead of 3 bonds to carbon, we've got hydrogen here, hydrogen here, hydrogen here, and iodine here. And we're reacting it with sodium T-butoxide. Whose structure is as follows. Does this reaction work? We know that one of them is going to give us the following. Methyl T-butyl ether. Well, in each case, we've got a rather strong nucleophile, right? We've got a charge on an oxygen. That's looking pretty nucleophilic. And we know that either one would be the result of an SN2 or an SN2 reaction, essentially, or an an SN1 or SN2 reaction. And we've got to determine which one will give us the product. Well, let's just consider the top one for a second. Would it be possible for an SN2 reaction to happen? No, because we've got a tertiary carbon with an iodine. That's not going to work out too well. What about an SN1 reaction? Would that be possible? That would be another way of getting the product we're looking for. That would be, iodine leaving, and then we get our carbocation, and then oxygen attacks. Is that possible? Well, it's not out of the ordinary. I don't think it's impossible, but consider what would happen if we did go that route. We're thinking SN1, and we end up with this tertiary carbocation and sodium methoxide. That's a negative charge. There's an issue here, and that's that we can also end up with an elimination product quite easily, right? This is definitely a competing reaction. Sorry, that's not an oxygen. I don't know why I drew an oxygen, right? That's entirely possible. And sodium methoxide, or just methoxide ion, is an incredibly strong base, right? We've, for SN1, we perhaps don't want to have such a strong base because we want to avoid side products, the elimination side product. So it's maybe possible to get the product we're interested in from the top option, but yeah, consider that elimination is going to be a huge issue. Well, what about this example, right? Now, we've still got a fairly strong nucleophile, and hey, just like with sodium methoxide, it's also a strong base. Do we have to worry about elimination side products, though? No, we don't, because we've got no acidic hydrogens, right? We don't have any neighboring carbons that have hydrogens on them that could create double bonds. There's nowhere to create a double bond. The only possible product we can get is the SN2 product, right? It's definitely not going to be SN1 because it's a primary alkyl iodide. It's definitely not going to be elimination because there's nowhere to form a double bond. So the only product we can get from this reaction is the SN2 elimination product, in which this negative charge attacks there and the iodine leaves. So the bottom method is far superior for that reason.